2025. My job was to set up times and tasks for other group members and make sure everything was going well.
My name is Aldrich Tamajon. My job is to deal with the report, and I assisted with fixing problems in parallel programming.
My name is Yuhan Yang, and my job is first is answer all the questions in parallel programming. Oh, not all the questions. Some of them is the last one is left to my teammates. And another thing I assist in is some of the coding parts, especially for the parallel threads and OMP part.
My name is Peter Ray, and I help with answering the questions and kind of researching a bit.
I'm Samantha Wolenik. My main tasks are editing the video and writing the report, but like everyone else, I also partly participated in the parallel questions and debugging. One of the most important things I learned was how to look at pre-written code and know the steps I should take to understand what's going on in the code and how to debug it and improve it. I think this is really important for the future because when you're given a task to look at old code, you know, the original writer's style might have been out of date or it's just not the same as yours, so you might have to take a few steps to understand what's really going on in the code in order to complete the task. I also learned it's really important to know the best time to use parallel versus sequential programming, because when you have a program that analyzes less data, then it might be best to use sequential rather than parallel, because initially the parallel does take a little more time to actually fork all the operations, so it might just be better just to use sequential. The most difficult thing for me was just understanding the difference between OpenMP and the C++ parallel. I know on the surface it's something about the map function in the OpenMP causes a possible overlap that'll slow down the program, but I don't exactly know why that does that.
I learned soft skills along with differentiating cases where single threading is faster versus multi-threading with regards to size and scope of inputs, along with the differences between OpenMP and C++ parallel, like Samantha said.
Yeah, what I learned here is first, is from the problems I answered. A kind of the parallel programming is called MapReduce. This is a kind that Google deal with the big data. So of course, I'm sure I will apply some of this in the future because maybe I will go to analysis the big data in the future. Another thing, well, it's not quite related to my major. It's a kind of the relation between proteins and ligands. Because, well, although I'm a CS major, I'm also curious about the biology. So I'm looking for maybe I will choose a biology degree in the future. So after that, I'm sure if I will apply that theory. The most difficult part in this project is to understand what the C code is saying. In fact, after the first time we type like the PPT and type just one parameters, and we find that it just changed the max number, the max length of legions. We cannot change the number of threads, so that's why I open the C file and see what's the input, which input is using to change the number of threads, and after that I find that I need two numbers before that, and the third number is the number of threads. That's why. In fact, it's not taking us so much time, but understand it at first. It's much more confusing because it's not very similar to the C coding we learned in season level class. It's not at the same level.
So what I have learned from this assignment were the four parts of building a parallel programming task: the decomposition aspect, assigning process, orchestration, and finally the mapping and scheduling. In details, I briefly remember a few things from each of those parts, but listing all of them would be time consuming and I cannot memorize them off the top of my head right now. Another thing I have learned is not exactly academic. It's more of a independency, is to not follow instructions word for word. What I learned here specifically for not following instructions word for word is again independency, and in the future, whether it comes to working on assignments or in real life, I feel like I would be better prepared to solve something on my own rather than having a supervisor or another expert just helping me out with it. But then again, I do also want to give credit to Walter and Yuhan, since they did help me out with my task in fixing the problems in parallel programming code. The most challenging thing was the ARM v7 error that I received, and also figuring out what each of the problems were doing. The ARM 7, it was just a weird error, and I needed Yuhan and Walter's help, Googling everything, looking at Stack Overflow, all other sources to finally solve that problem, and figuring out what all the programs were doing. Serial was easy to understand, but OpenMP, the difference between OpenMP and using C++ threading was a bit more difficult to understand, but eventually I did manage to understand it in the end.
My most important and probably the hardest portion of the assignment for me was installing the TBB package, because our Pi didn't initially have that. I had the Pi initially, so I downloaded the droid files and tried to see if everything would run, and they wouldn't. The concurrent vector.h portion of the code wasn't found anywhere, so I had to Google and download all the library functions for that, and I still got errors, so with the help from the team, we finally got through it. And for the main application of the project, it's really what Samantha had said, sequential versus parallel programming. There are some situations where sequential is going to be faster and others where parallel, but knowing which to use is going to be invaluable in every job I have. And learning that there's more than one way of handling it with the parallel code is going to also be invaluable.
I noticed that I forgot the other two parts, so I'm going to say those now. The hardest part was researching the answers to the questions I had. I couldn't really find the answers, and those guys helped me out a lot. And I can use this knowledge to know when to write code to be executed in parallel versus in series.
Cool.
Nice.